Okay, welcome to Lesson 6. This is Lesson 6 from Unit 6 of Algebra 2. This lesson is about writing equations of quadratic functions. So we're going to look at how to write the equation given a variety of different pieces of information. These questions can range from pretty straightforward to somewhat challenging, so let's be sure we give this our best effort because it is really an important skill. So here we go. We're going to write the equation of a quadratic function with zeros of -6 and -2 that contain the point 0, 48. So because we are given zeros, remember that zeros are connected to factors. So if you're ever given the zeros, you should just simply write your equation in factored form. So if one of the zero is -6, we know that x plus 6 is a factor, and x plus 2 is a factor. But what we don't know is the leading coefficient, which could be right here. We don't know what that a value is. It could be a fraction. It could be 2 or a negative. So we need to have some other piece of information in order to find the final equation. The additional piece of information we have here is that the graph contains the point 0, 48. So what I'm going to do is I'm going to put 48 where the y is and 0 where the x is and solve for the missing a parameter. This is 48 is equal to a times 6 times 2, which is 12a. 48 divided by 12 is 4. So our equation then is y is equal to 4 times x plus 6 times x plus 2. And that's it. All right, so I have a problem similar to that for you to do for practice. So take your time and do it right now. All right, let's check your answers. Because they're x-intercepts, we know x-intercepts, which is, are also zeros, that they're related to the factors, that if an x-intercept is -1, we must have a factor of x plus 1 and a factor of x minus 5. And we don't know the a value. So we know it goes through the point 29, so let's plug in a 9 for y and a 2 for x. So we get 9 is equal to a times 3 times -3. Which gives me 9 is equal to -9a. So a is equal to a -1. So our equation is, and we can just say negative, we don't have to put the 1, negative x plus 1 times x minus 5. And that's it. All right, let's take a look at another example. For this example, we have to write the quadratic function with a vertex at 5, 8 that contains the point -1, -10. If we're given the vertex, we should start with our transformation, our vertex form. Hopefully you remember that it's a times x minus h squared plus k. Remember, insiders lie, so the vertex is actually the opposite of the number with x. So we don't know the a value, but we know that the vertex is 5, 8. So it goes just like that. Now we've been given the point -1, -10, so let's put -10 in where there's a y and -1 in where there's an x. Which gives me -10 is equal to a times 6 squared, -6 squared I should say, plus 8. So that becomes a -18 is equal to -6 squared is 36. I'll write it down like that and divide both sides by it. And we get a is a -1/2. So my answer is y equals -1/2 times x minus 5 squared plus 8. All right, now it's time for you to try. Okay, let's see how you did on this one. Got a vertex of 1, 2, so it should be x minus 1 squared plus 2. I'll put the point 4 where there's a y and 0 where there's an x. So that's a negative 1 squared plus 2, which is becomes a positive 1 times a. So 2 is equal to a. So my equation is y is equal to 2 times x minus 1 squared plus 2. And there we have it. All right, for the next one, we need to write the quadratic function through the given 3 points. So this is the hardest way to do it, I think, because they're not giving us zeros, they're not giving us a vertex, so we're stuck with just plain old standard form, y equals ax squared plus bx plus c. This one's not too bad because they gave me this point here, which you'll notice is the y-intercept. The y-intercept is what you get when you plug a 0 in for x. So what it's saying is that if I plug in a 0 for x, I would get 0, 0 plus c is equal to y. So this is actually telling me the c value. So we actually know that this equation is sum a x squared plus bx minus 6. So the only things left to find are a and b. But since those are two different things I do not know, I need two different points to write two different equations, and then I'll have to solve a system of equations. So let's use the first point. Negative 2 for the y, negative 4 for the x. So negative 4 squared is 16, so that becomes a 16a minus 4b, and then minus 6. I know that 6 looks a lot like a b. This is a b, and that's a 6. But I'm going to add 6 to both sides, and I'll get this to be 4 is equal to 16a minus 4b. And I'm actually going to go ahead and divide through every single number by 4, because I can do that, and give me 1 equals 4a minus b. All right, let's try the next one. The next point we are given is 2 comma 4. So I'll do that one over here. So I put a 4 in for y this time. And I put a 2 in for x. So a times 2 squared plus b times 2 minus 6. So 4 is equal to 4a plus 2b minus 6. Then I'll add that 6 over. I get 10 is equal to 4a plus 2b. Then I'll divide everything by 2, and I get 5 is equal to 2a plus b. So now I just need to solve a system of equations between these two equations there. That was a terrible star. There we go. Those two there. So I'll just write this one right underneath it. You'll notice it's actually set up perfectly for me to just add the two equations together. And the b's cancel out, and I get 6 is equal to 6a. Divide both sides by 6, and I get a is equal to 1. So then if a is equal to 1, I can use either one of these equations to solve. I'll use this one here. That was a minus. I know it kind of looks like a plus now. And let's see here. A was 1, so it's just that. And so I have a negative 3 equals negative b, so b is equal to 3. So we've done all this work. Let's make sure we write down our final answer. Our final answer is y equals a is 1. So it's just x squared plus bx, so plus 3x minus 6. This parabola goes through those 3 points. Let's check. Okay, so I'm going to just simply type in my equation here. Y equals x squared plus 3x minus 6. Actually, I'll use function notation. I'll say f of x. And we can see f of 0 is negative 6, f of negative 4, and f of 2. And you can see that that graph is definitely going through each one of those. There's 0, negative 6. There is 2, 4 right there. Somewhere around there. Well, there it is. And then at -4, we'll see here, we should have -2. Yeah, right there. Okay, so I think we did a good job. All right, this next one here is actually a little bit more challenging because you'll see that we have 3 points again, but this time none of them is a y-intercept, so I don't automatically know the c value. So I'm just going to have to start with y equals ax squared plus bx plus c, which has 1, 2, 3 parameters that I don't know that I need to find out. So I'll need 3 points to make 3 different equations and solve that system. Let's start with 2, 7. I'll put a 7 in for y and a 2 in for x. I'll write that as 2b and then plus c. So that's 7. 2 squared is 4, so it's a 4a plus 2b plus c. Next, I'll do the 3 and the 9. So I'll put that there. 9 is equal to a times 3 squared for ax squared plus b times 3 plus c. So if I can just rewrite that a little bit, that's 3 squared is 9, so that's 9a. I'm just going to put the constants in front of these variables here. Plus c. Okay, one more to do, 13 and 4. So I'll say 13 is equal to a times 4 squared plus b times 4 plus c. Remember, I'm just replacing the x with that x value in this equation, okay? And 4 squared is 16, so I get, oops, wrong place to put 16. So I get 16a plus 4b plus c. And we need to just solve this system of equations. So here we go. 7 equals 4a plus 2b plus c. And I'm going to rewrite this times a -1. So it's a -9, -9a minus 3b minus c. And I will add these two equations together, and I get -2 equals a -5a minus b. So remember, when you're doing this, because there's no x on the c, you're going to be able to cancel c really easily on between two of your equations. So that was the first two. Let's do the next two this time. So I'll do 9, and I'll keep it negative again. I multiply that by a -1. So I have -9 equals -9a minus 3b minus c. And then I'll put my other equation right underneath that, 16a plus 4b plus c. So the first time I solved using this equation and that equation. The second time I'm using this equation again, but with this equation. I need to have a different pair of equations. But because I multiplied this one by a negative, those c's are ready to cancel out. So I have a -4, oh, not -4, +4. +4 is equal to 7a plus b. Okay, well, actually, these look perfect for elimination again. So I'm just going to take this equation and move it over there. And we'll add them together. And the b's cancel this time. And I'm left with 2a is equal to 2. So a equals 1. And I can use one of these equations. I'll just use this one here, that 4 is equal to 7 times 1 is 7 plus b. So -3 is b. Lastly, I need to find c. I'll use this equation over here. 7 is equal to, my a value is 1 times 4 is 4. Plus my b value is -3, so that's a -6 times, so because it's times 2, and then plus c. So 9 is equal to c. So our equation is y is equal to x squared minus 3x plus 9. And barring any mistakes, that should go through those 3 points. Let's check it out. So again, I'll use f of x. That's going to allow me to plot some points with it. And I'm just going to put these points on it. So let's see here. The first point was 2, 7, right? The next point was 3, 9. And the last point was 4, 13. Okay, looks like we did a pretty decent job there. That's the parabola. Notice that's the one and only parabola that goes through those 3 points. 3 points define the parabola. If you're given the vertex, you only need the vertex and one other point. But if you're not given the vertex, you need 3 points. Okay, it's time for you to try. You've got one that you have the y-intercept and another one where you do not. So give it a shot, and then that will conclude this lesson. So pause the video, give it a shot, and then we will go over it. All right, so because we don't know the vertex or the x-intercepts, we need to use y equals ax squared plus bx plus c. If you plug in a 0 for x, you just get y equals c, which that means is that when x is 0, the y is c. So when I say 0, 1, I'm telling you the c value. That is the y-intercept. So we actually know that this equation is ax squared plus bx plus 1. I'll use the other 2 points to set up a system of equations. I'll put a -1 in where y is and a 2 in where x is. I'll subtract that 1 over, making this a -2, and then that's 2 squared is 4, which I'll write in front of the a, plus 2b. I'll then divide through by 2, because I can. It makes the problems a little smaller. I might need to multiply by 2 again later, but that's okay. So 1 down, 1 to go. Let's do another one. 3, 8. So I'll write it up here. -8 for the y, so -8 is equal to ax squared, so a times 3 squared plus bx, so b times 3, and then we had a plus 1 for our c. So subtracting 1 from each side gives me -9 is equal to 3 squared is 9, so 9a, and then plus 3b, which I will then divide through by 3. So I have a -3 equals 3a plus b. So I've got 2 equations, 2 unknowns. Let's solve the system. I'll just rewrite them. Actually, I'm going to take this and I'm going to times it by a -1, okay? So that's going to become a plus 1 is equal to a -2a minus b. Add the 2 equations together, and I get -2 is equal to a. I can find b by simply solving it into one of these equations. So that's 1 is equal to 4 minus b. So b is equal to 3. 4 minus 3 is 1. So our final answer is y is equal to -2x squared plus 3x plus 1. And again, I'm just going to double check my work here. -2x squared plus 3x plus 1. And the points we're supposed to go through are 0, 1, 2, -1, and 3, -8. Let's see how we did. All right, there they are in all their glory. Okay, one more to go. And this is the one where I don't have a y-intercept, and none of those are x-intercepts, which would help as well, but we'll just have to use each one. So we're using y equals ax squared plus bx plus c. So first I'm going to plug the 1 in for the x, and the -5 in for the y, which gives me a plus b plus c. Next I'm going to plug the 2 in for x, and the -2 for y. 2 squared is 4, so that'll be a 4a. b times 2 is 2b, and plus c. Notice the pattern that it's the x squared, and then just the x, and then no x at all. All right, then I'll plug in a 3 for y and a 3 for x. 3 squared is 9, so 9a plus 3b plus c. There's my system of equations. I'm going to multiply the top equation by a -1 and combine it with the middle equation. So 5 equals -a minus b minus c, and then the middle equation I'll keep the same. If you're wondering, we could indeed set up a matrix to solve this equation, and I think I do that on my homework answer keys every so often just to keep you on your toes. It's totally possible. If you prefer a matrix, you can use a matrix and reduce row echelon form. Adding those makes those cancel, and I get 3 is equal to 3a plus b. All right, next I will use the top equation again, but this time in the bottom equation. So we multiply the top equation by a -1. And the bottom equation will look like this. Adding them together gives me 8 equals 8a plus 2b. I'm going to divide this by 2, giving me 4 equals 2. Not 2, sorry. 4a plus b. All right, I need to solve these two equations together. I'm going to multiply this by a -1. And I get -3 equals -3a minus b. Adding them together, 1 is equal to a. Now I'll get b. I'll use this equation here. 4 is equal to 4 plus b. So according to this, our b value must be 0. All right, now that we know that, we can get the c value. I'll use this original equation here. -5 is equal to 1a plus 0 for b plus c. So -6 is equal to c. So our equation appears to be y equals x squared minus 6. And we could just check it by plugging in. Plug in the 1 and -5. 1 squared is 1, minus 6 is -5. Try the 2, -2. 4 minus 6 is -2. And the last one, 3 squared is 9, minus 6 is 3. So we know that it works. And that is all for this lesson. And I will see you in the next one.